Welcome back to our sessions together. We're going to look at exponents. I'm going to go through the exponents once again. We're going to do the recipes the same as we do with all the others, okay? What we're going to do is we're going to build up a specific sequence of events, okay, that you have to do. What is an exponent, just to sort of re-go over it? Remember, we have something to a power. So we have A and we have a B up there. Okay? Right? This is called the base. This is called the exponent. Okay? Essentially, it's the power. Squared, cubed to the fifth, or whatever the case might be. Even we're going to get to the halves and the 2/3 as well. All right? But it's something to a power. All right? And the base is, it could be x or it could be a number, right? Don't forget, you could have x at the top or x at the bottom. Doesn't matter. You could have two numbers, 5 to the power of -3, all right? Now, I'm assuming that everybody is very au fait with the whole concept of negative exponents and things and the basic laws, okay? That you will be covering, I'm pretty sure, in class as the run-up to starting exponents. Just the basics are going to be. What I'm going to do is I'm going to take you through, you're going to get a whole set of stuff too. The first thing they're going to ask is they're going to say simplify. Right? And generally speaking, if you're looking at patterns here, you'll see that this is often happening. We do simplify, we do a whole lot of different ways of simplifying something, and then we go on to solve for x, right? That's exactly the same here. We're going to do the same thing. We're going to learn how to simplify first, some tricks and techniques to do that. Then we're going to go into exponential equations, where we're going to apply the simplification in order to solve the equation, all right? Now, let's have a look. They give us stuff, all right? Let's have a look at, first of all, the recipe. Step 1. Step 1 is write all numbers as prime factors. Okay? Write all numbers, bases. Okay? Write all bases as prime factors. Okay? So whatever base, if we've got 27, let's say, we write that as 3 to the power of 3, right? We change those to that. Step 2, all right? We're going to remove the brackets. You'll see exactly what I mean now. Remove brackets. We've got stuff in brackets. It could be 3 to the power of 3, and we could have x plus 2 on the outside, right? Remove these brackets, remembering that a bracket means times. So we're going to multiply. So this becomes 3 to the power of 3x plus 6. Remember that the 3 times is everything. That's the first big source of errors that I see. People, we forget to multiply everything, okay? So when you're doing it, don't forget to multiply it by the 2, okay? Okay, then we're going to go step 3. Will be split. If we see something like this, 3 to the power of 3x plus 6, right? Let's remember that that is the same as 3 to the x times 3 to the 6. Why? Oh, sorry, 3x. Because if the bases are the same, what do you do to the exponents? If I've got 3 to the power of x multiplied by 3 to the power of 5, that is 3 to the power of x plus 5. If I've got 3 to the power of 2x minus 2, that is 3 to the power of 2x, 3 to the minus, well, but we don't use negative exponents. So we change, and this is step 4. Okay, change all negative exponents to positives. Okay, you don't want to work with negative numbers. Okay, it's crazy. Why? It just makes it complicated. So we change them to that. Now, let's have a look. So therefore, that would become 3 to the power of 2x. This is on top, so it goes underneath, and it becomes 3 squared. Right? It becomes 3 squared underneath. Similarly, if I had 1 over 3 to the minus 2, that is, it becomes positive, it moves to the top. Correct? Remember those? Okay, let's move along. Then we get to step 5. Everybody's happy place. Cancel out. Once again, okay, remembering you've got multiplication signs in all of this. Let's test the recipe for this, shall we? They have given us here, simplify. Okay, 16 to the power of minus 1, x to the power of 3, y to the minus 2, over 2xy minus 1, all to the minus 3. Simplified. Step 1, prime factors. 16 is going to be 2 to the power of 4. Okay? Multiplied by x cubed, y minus 2. Okay? Remember, don't do too many things at a time. What happens underneath? 2 to the minus 3, x to the minus 3, y to the plus 3. Why? Because this means multiply. And every single item in there must be multiplied by it. When you multiply the brackets out, you multiply by everything. When you multiply the exponent into the bracket, everybody gets that exponent, right? Then I said, right, the next step is remove the brackets. So that becomes 2 to the power of 4, x cubed, y to the minus 2, 2 to the minus 3, x to the minus 3, y to the 3. Okay? Now what we said next, we make all negatives positive. So draw a line. Start here, guys. Start at the top there. That is, it stays on the top of the table. It's positive. X cubed stays. Y squared goes down because it's a minus 2. So it must go under and become squared. All right? Then we finish there. Now let's go to the top. 2 to the minus 3 becomes 2 to the 3. X to the minus 3, x to the 3, and y3 stays at the bottom. Okay? What do we end up with then? Now we can say, okay, let's first of all say, all right, let's see if we can cross cancel anything here. Okay, can you see? I already had a mistake there. I forgot the minus 1 out of it, right? It's a minus 1, so my bad. That 2 to the minus 4 goes down as 2 to the 4. Okay? All right, let me just get rid of it. Okay, 2 to the 4. So now let's cross cancel. Okay? Right, green. X cubed, no. 2 cubed, yes. Leaving me with 2. Because that's 2 times 2 times 2 over 2 times 2 times 2 times 2, right? 2 cubed over 2 to the 4th is that. Cancels, leaves us with 1 over 2. X squared, so I end up with nothing, right? On top, therefore, we end up with x cubed, and y squared, y cubed, which is x to the power of 6, y to the power of 5, okay? Okay, and my 2 at the bottom, all right? Now, that's a fairly straightforward one, okay? Here they've now got one where they've introduced more negatives and brackets and blah, 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 blah. Let's just do the same recipe to it, right? It looks complicated, but, well, maybe it's not as complicated as we thought. Let me write it down correctly. 28 x to the 6th, y to the 4th, over 4x to the 4th, y to the 5th, z to the minus 2, divided by 21 x to the minus 2, y to the 5, over z to the minus 3. Okay? Right, what is the... hang on. There's a step in my process missing. Okay? Always we've got... What is this? You need to tip and times. So let's rewrite 28x to the 6th, y to the 4th, over 4x to the 4th, y to the 5th, z to the minus 2, times z to the minus 3. Remember? Okay, it's gone up. 21, x to the minus 2, y to the 5. Next step, prime factor. 28. What's 28? If you're unsure, some calculators, some of the new silver ones apparently have got a button that does the factorizing for you. But let's see. We say 28. 2 goes in there, 14. 2 goes in there, 7. So it's going to be 28 is 2 squared times 7, x to the 6th, y to the 4th, over 2 squared times x to the 4th, y to the 5th, z to the minus 2, multiplied by z to the minus 3, over 21 is going to be equal to 3 times 7, okay, to the x minus 2, y to the 5. Right? Now, I know we all want to get happy and cross cancel, but we've got negative powers still. Okay, negative exponents. So let's first of all now get rid of them. Okay, remove the brackets. There's a 1 outside, so that's 2 squared 7, x 6, y 4. Right, underneath 2 squared, x 4, y 5, z minus 2. z2 goes up. Multiplied by z minus 3, z3 goes down. Okay, and on top, okay, that's everything. Now I carry on. 3 and a 7, correct? Like that. X minus 2 goes x squared, y 5. Okay, stays there. All right? All right. Then the final thing, now we're going to have a look at some cross cancelling. Let's have a look. 2 squared cancels with that. We always start here. 7 cancels with that 7. Right? x6 cancels with that x4, leaving us x2. y4 with the y5, leaving us with a y at the bottom. Z squared cancels with that, leaving us with a z at the bottom. Right? And the x squared now has nothing left to cancel. And basically that's it. All right? Most of it has now gone. So what's my final answer? On top, we've got x squared and an x squared. Okay, x squared, x squared. At the bottom, there's a y there, a z there, and a y5. Now we group and add, so at x to the 4th over y6 times z. All right? Now, that looked a lot worse than it actually was. All right? Let's have a look at simplification of this one now. Right? This is 8 to the minus 1. This is another example. Remember, the only way to get value out of these is to actually write it down and then go through the processes with me. Look at what I'm doing. And because you can stop it and start it, you can actually see how the process works. Once you've got these recipes in your mind, they go very fast, right? So let's have a look. This is 8 to the minus 1, all right? X squared times y to the minus 2 over 2 in brackets x, y minus 1, all to the minus 3. All right. What did I say? Step 1, write all bases in terms of prime factors. 8 is going to be 2 to the power of 3, okay? And that's to the minus 1. X squared, y to the minus 2. This is already, so we can remove the brackets here. You don't have to. You can do it all in one when you're doing it. Okay, let's leave it till we get to the x, y minus 1, or minus 3. Okay, all prime factors are done. Now we remove brackets. That's 2 to the minus 3, correct? There. X squared times y minus 2 over 2 to the minus 3. Remember, that must be included. Every single one. X to the minus 3, y to the plus 3. Okay? Next step, get rid of negative exponents. Starting, draw a line. Start over here, always. Always start here and move across and then go to the bottom. 2 to the minus 3 must go down to be 2 to the 3. And that remains x squared, and y squared goes down. Then that 2 to the 3 comes up, x to the 3 comes up, and y3 stays down. Okay? Now we look and we say, right, now we're in the happy spot. Let's cross cancel. X squared, right? No, nothing underneath. 2 cubed, yes, with u. X cubed, no, nothing underneath. The net result is we're ending up on top with x squared, x cubed, over y squared times y cubed, which is x to the 5th over y to the 5th, which you could rewrite as x over y all to the 5, right? Because remember, 3 over 4 all squared is 3 squared over 4 squared, which is 9 over 16. All right? And let's have a look. That is basically 3 over 4 times squaring itself. Equals 19. 9 over 16. All right? So I've just simplified that down like that, right? Which you may do. Okay? Now, let's have a look at another one over here. Here's just one with numbers. This one is and when they're testing, they do like to do these, they do enjoy giving you these kind of ones. And then I'll also show you a trick one in a little bit. Simplify 2. Here we go. This is another example. 2 over 1 over 8 to the minus 1. Right. First of all, prime factor. 2 over 1 over 2 cubed to the minus 1. Right? Can you see the 8 has become 2 cubed? That's our prime factors. Secondly, remove brackets. Can you hear the recipe yet? Is 1 to the minus 1 over 2 to the minus 3. I've now moved that inside the bracket. Now, let's change these powers. 2 over, that must flip, and that one goes there. That becomes 2 cubed over 1 cubed, right? Which is going to end up as 2 over 2 cubed, which is 1 over 2 squared, which is 1 over 4. Okay? Can you hear the recipe coming through? Once the recipe is in your mind, the rest is just practice. Okay? Maths, I know, I had the debate the other day with a colleague about maths, a learning subject. I guess it has its learning elements, especially in geometry, but essentially there's not a lot of stuff you have to commit to memory. There's a lot of learning in regarding techniques to do things. But that, I tend to say, that comes from practice. That's the only way to be good at maths, and for you who are watching this and want to extend yourselves and get higher results, it's practice. Once we've gone through the recipes, it's practicing them and then building up your speed. Okay, once you've got it, you'll fly through these things. Okay, the next one is this. Simplify. Okay, here we go. It's this one. 15a b cubed c minus 1 over 12a to the minus 2 b squared c minus 3. All right? Right, step 1, all right, is that is 15 is 3 times 5. Okay? To the a b cubed c minus 1 over, what is this one? 12 is 2 squared times 3, 4 times 3, right? A minus 2, b squared, c minus 3. Next step, remove the brackets, okay? I'm going to do that and say that's 3 times 5 times a times b cubed times c minus 1 over 2 squared times 3 times a minus 2, b 2, c minus 3, right? What do we do? Now negative powers must become positive. That is 3 times 5 times a times b 3, draw my line, c gone down. Okay, remember I started there and worked that way. Over 2 squared, 3. That a minus 2 goes up and becomes a2. B squared stays, and the c minus 3 goes and becomes c3. Now I take out my cross-cancelling pencil, and I say, right, the 3 cancels with that. The 5 with nothing, the a with nothing. The b goes to a b, and there's a b. That's gone, right? Let me just get rid of that. That's gone. Because that was b times b times b on top, b cubed, over b times b. So it cancels, leaving us with a b. Okay? Happy with that? Okay, then the next one, I go along and I say, now my a, nope, c, yep, there I can cancel c squared and a c. All right? So let's see, what are we left with now? We are left with on top a 5, an a squared, and a c squared. And at the bottom, a 2 squared, and that's it. Okay? Is going to end up, therefore, now we can group them, see? Same basis, so we add 5a cubed c squared over 4. Okay? Here's another simple one, all right? Here's one simplify here. All right? Is x cubed y minus 4 multiplied by x minus 3 y 4. Right, remove the brackets, okay? Right, how are we going to remove the brackets? Well, let's have a look. First of all, what do we do inside here? x3, there's a 1, by the way, inside the brackets. So if I remove them, it becomes x3 y minus 4, x minus 3 y 4. Okay? Then I make all negatives positive. Start here, that stays x3. y4 goes down. Okay? X minus 3 goes down, and y4 stays. Okay? So green cancel, x3, x3, y4, y4, and my great answer is 1. All right? Same process, or we could have just done it inside the brackets like that. x3 over y4 multiplied by y4 over x3. Remember, 2 to the minus 1 all to the minus 2 is equal to, first change in the brackets, right? Okay, let's just change in the brackets. What's that going to be? That's going to be 1 over 2 all to the minus 2. Okay, like that. That minus 2 comes in, it's 1 to the minus 2, 2 to the minus 2. Now, the 1 must go down below, the 2 must come up. The answer is 4 over 1, which is 4. Just can you see the method to do these, right? This is, well, I suppose it's arguably the rocket science or whatever, but essentially this is the method that we're going to use for these, all right? I know they get very long, they get very complicated, they get in essence very tedious, okay? All right? Now they're going to give us, and they're going to say simplify this, okay? This is slightly different now. Okay? 12 to the power of n plus 1 times 9 to the power of 2n minus 1 over 36 to the power of n times 8 to the 1 minus n. Right. Now I'm going to bring in that split term. Okay? Prime factor was number 1. If you go right back, we said, well, you guys, you can page back to the first one and see. We said prime factors, right? 12 we know is going to be 2 squared times 3, all to the power of n plus 1, right? That is multiplied by 3 squared 2n minus 1. All over 36 is 2 squared times 3 squared to the power of n, multiplied by 2 cubed to the power of 1 minus n. Prime factors, done. Remove brackets, in other words, multiply out. Remember the 2 there goes on both. So it becomes 2 to the power of 2n plus 2 times 3 to the power of n plus 1, because there's a 1 there, okay? Times 3 to the power of 4n minus 2, right? Over, now, 2 to the power of 2n. And 3 to the power of 2n. Multiplied by 2 to the power of 3 minus 3n. Okay. Right, we've done that. Next step, split. Okay. So we now go on and we say, right, split. Right. Can you see here was prime factor. Here was brackets. Now we're going to split. What are we going to split? We're going to split this. All of these here, we're going to split them up. Why? Because then we can cancel it out. Okay? So we're going to have 2 to the power of 2n times 2 to the power of 2. 3 to the power of n, 3 to the power of 1. Can you see? That's the n plus 1 split there, right? And 3 to the 4n, 3 to the minus 2, over 2 to the 2n, 3 to the 2n, 2 to the 3, and 2 to the minus 3n. Can you see that one? 2 to the 3 minus 3n is 2 to the 3 multiplied by 2 to the minus 3n. Okay? Right. Next. Okay, what is the next step? Okay. The next step of this, we've now split it. Negatives must become positives, right? Remember? Okay. Negatives become positive. So, we first of all, we say 2 to the 2n, 2 squared. 3 to the n, 3 to the 1. 3 to the 4n, right? And at last, we've got 3 squared there. Then I go 2 to the 2n, 3 to the 2n, okay? 2 cubed, and at the top goes 2 to the 3n. That one has gone upstairs now, right? To become positives. Now I take out my cancel pen because now I'm happy. Now I can get going and I can cross cancel all of this. Where do I start? I start at the top. Here. Always there. 2 to the 2n, yes, there it goes. 2 squared cancels with this one, leaving me with a 2. 3 to the n cancels with that one, leaving me with 3 to the n. Okay? 3 there cancels with that, leaving me with a 3. Okay? 3 to the n over here, okay, is going to end up as what? Okay? A 3 to the n over there is going to cancel out that 3 to the n with leaving 3 to the 3n. There we go. All right? So what am I left with at the bottom, on top, okay? We're left with on top, what? Okay. Let's see. Just change this to black and go up a bit, okay? We are left on top, let's see, there's a 3 to the 3n and 2 to the 3n there. Over the bottom is a 6, all right? Now you could, if you want to, group that, okay? And you could say, okay, that is there, is they are both to the same exponent, which means I could bracket that 3 times 2 all to the, can you see I'm putting them back in the brackets? If I multiply the brackets out, it's that and that, isn't it? So over 6, which is 6 to the power of 3n over 6. Hey, can I cancel that 6 out? Not on your life. because that is 6 to the power of something and a 6 at the bottom. It does not become 3n, okay? Just remember, that's an exponent, and that is 6 to the power of 1, all right? There. You can take this one step further. 6 to the power of 3n times 6 to the minus 1, which is 6 to the power of 3n minus 1, all right? That's entirely arbitrary. I don't like doing it. I like leaving it as positives. I don't like putting a negative exponent back. But hey, you know, that's a matter of peculiarity and taste. Okay. Well, we've done a whole pile of those now. Okay. We're going to do some more. We're going to do quite a few more of examples I've got here. All right. But I'm going to start going into factorizing very soon. Okay, as well. Just another step in the recipe. Like we've got the recipe now is for a scone. The factorizing is we're going to stick blueberries into it and make a little adjustment. At this point, put in the blueberries, right? That's what this is all about. See you in the next session. Thanks for listening to that one. I hope you enjoyed it as much as I did. Let's take the mystique out of this stuff. Cheers.